Yes. Are you working out? Deepti, tell me how are you going to solve this question? I hope I'm audible. Deepti?
Yes, ma'am.
Yes. How are you going to solve this question? Just give me the idea. I don't want mathematical steps here. Just give me the idea.
Ma'am, we can find the mass phasing, mass deposited by using density and area into thickness, ma'am.
What formula is this? Density is equal to area
Mass,
into thickness. Ah. What is this?
density into
Ah,
volume, ma'am.
very good.
Volume is area into
Very
thickness.
good. That's the right one here. Deepti is right. You are provided density of silver here and you are provided with the area and thickness here. So, density is equal to mass by volume. So, area into thickness will give you the volume here. But remember, it is in millimeters, so you have to convert it into centimeter multiplied by 10 power minus 1. Multiply density with your volume, that will give you mass here. What should be the next step? Rima, what will be the next step, Rima? After you calculate that, what will be the next step? Please be faster.
Ma'am,
Hmm.
we have to use that formula. Uh, Mass equal to Z into I into T.
Correct. Okay. So mass you will
Using
be
that
calculating from that. What will be your Z value here?
uh, equivalent weight by 96,500.
What is the equivalent weight here? What will be the equivalent weight here? Yes, Kagol, tell me da. Anyone who is ready can please give the answer. Don't wait for my calling.
மேம் மோல்ஸ் இன்டூ ஃபேரடே போட்டு
Hmm.
அதுக்கப்புறம் கியூ ஈக்குவல் டு ஐடி ஃபார்முலா வச்சு போடும்.
சரிடா. இப்போ நீங்கள் கால்குலேட் பண்ணியிருக்கிறது மாஸ். அதுலேருந்து என்ன பண்ணுவ? மோல்ஸ் கால்குலேட் பண்ணிவிட்டு ஐ இன்ட்டு
மோல்ஸ்
டி
கால்குலேட்
போட்டுடலாமா?
பண்ணும் மேம். மோல்
ம்.
ஆ
ஓகே.
மோல்ஸ் கால்குலேட் பண்ணிட்டு கியூ ஈக்குவல் டு ஐடி ஃபார்முலாவில் போட்டு போட்டுடலாம்.
Okay. Other way is that you, as Rima is entering, m is equal to z into I into t. After you calculated mass, z is the equivalent weight of silver. Silver oda equivalent weight enna? The n factor is 1 year. So it is 108 divided by 1 itself. Yes. Yes or no? So you can see this, it is
Yes, ma'am.
108 divided by 1 and the Faraday constant 96,500 here. I into t is used to get your answer. Okay. Next question. Vaishnavi, next
Second
question.
option.
Second option.
Second option.
That's the right one here. So the combustion of hydrogen is happening to create a potential difference between the two electrodes. But of course, when it is happening, it will produce high purity water, it will generate heat, everything will happen. But this combustion is happening to create the potential difference between the two electrodes. Okay, next. Tarun, tell me the steps. How are you going to do this problem?
1 minute.
Hmm.
First, we can find the delta G of the reaction.
Okay.
Delta G of products minus
Hmm.
delta G of reactants.
Okay.
Uh, not finding any idea, man. Like I'm confused with the term efficiency.
Hmm. Actually, this method, or what you're saying, the first step is right. You are provided with all the values here. You calculate the delta G naught of the reaction here. This is your combustion reaction, isn't it? This actually, if it is happening, the standard enthalpy of formation should be minus 726 here. Okay, but as you're doing this one, you find the answer to be minus 702.6. Actually, your expectancy is minus 726, but how much you get? 702.6. So the efficiency is dividing it by 100, multiplying by 100. Okay,
Got it.
good. Kabul.
Ma'am,
Hmm.
1 second. Ma'am,
Hmm.
B, ma'am.
Why B? Ag solid is becoming Ag plus, isn't it? So it is oxidation only, na? Why is
Yes,
there a
ma'am.
question there?
Okay.
Prithviraj,
Ma'am,
tell me. Da.
ma'am, can third option be the answer, ma'am?
Which one, Ra?
Br minus gets oxidized.
Could also be an answer here, but here it is a kind of an metal ion electrode reaction. Okay? Since it is aqueous and liquid, no such kind of, though you can see from -1 it is going to 0, ma'am. It is oxidation only, na. But whenever these kind of questions provided, go for your metal ion electrode part basically. And look at the question, they are asking about the anode here. Miduna,
Yes, ma'am.
the question is about the anode here. Okay. So there is a competency for this to happen here. Okay.
Okay, ma'am.
You would have learned the cell representation. Left hand side is anodic, right hand side is cathodic. This side, look at this. This is anodic, this is cathodic. Okay.
Yes, ma'am.
But ma'am, they have provided the reverse term. Please study your classwork for metal ion electrode. The right hand side, the equation will always be given in the reverse pattern. You usually see this brom reduction should happen, na? Br2 then Br minus. For metal ion electrode in the right hand side, we actually write it the reverse pattern. Understood, Ra?
Yes, ma'am.
Okay. Yes, go on, go on. Anyone can answer faster?
Third option.
Very good. That's the right one here. Coming for your dry cell battery reactions. Ammonium chloride, when it reacts with zinc, releases ammonia as well as hydrogen here. Okay. Ma'am, they mentioned colorless. Why not ammonia? Ammonia is not in this option at all. Next one.
Second option, ma'am.
Second option, very good. Justify your answer.
Uh, in the first case, ma'am, we get 0 point in the log 0.01 by 1.
Hmm.
So when we take out it, it gets plus, ma'am. So
Okay.
when we reverse it, it again becomes minus in
Very
second case.
good.
So
That's the right answer. Very good, Srinidhi. So you know that zinc is the one which will get oxidized, copper gets reduced. So this is the way you usually write your Nernst equation. Now you find that the zinc concentration has increased, Zn2 plus 1 molar and copper 2 plus is 0.01 molar. So the factor is higher here. If it is getting higher, that means the negative increases. So it should go down. So I understand E2 will be less than E1. Everyone understood?
Yes, ma'am.
Oh, next question. Mithul, can you answer?
No, no, please do it.
Hmm. Faster, quick. Be louder also. Okay, Srini, the answer.
is it second option, ma'am?
Don't give me is it. No is it and all.
Second option.
No. More is the positive reduction potential, more
Third
will be the
option.
deposition, na? Why did you miss magnesium here, Srinidhi?
Hmm, I thought it wouldn't get reduced easily.
It's not about getting reduced easily or not. We are just asking for the correct sequence.
Okay.
Quantity they missed magnesium here. Okay. Your patterning is right. More is the positive reduction potential. More is the reduction possibility or the deposition possibility. Okay. Yes. Miduna, answer. Diya? Diya? Kadu mooduma. Yes, Miduna?
1 minute, ma'am.
Okay. Da.
Second option, ma'am.
Why?
Ma'am, in anode, oxidation of water will occur, so H plus ions will be released, I thought, ma'am.
What kind of a solution is this? Is this a buffer solution?
Yes, ma'am.
Then what will a buffer solution do? As you're trying very beautiful understanding. Water reaction is happening, fine. But what is the role of buffer there? Don't you think it
It will
will
maintain the pH, ma'am.
maintain the pH? Huh? So the pH of the solution both remain practically constant because it is a buffer solution. Tarun, answer pa.
Yes, ma'am. Ma'am, 1 Faraday is required for um, 108 gram of Ag, ma'am.
Okay.
So 0.01 would give us 1.08, ma'am.
Mm. So your answer is this. Look at the question. The silver content of the beaker after the above shall be. After passing this, what will be the weight of silver content there? You have come to till the last step. What you are saying is right. 108 gram for 1 Faraday. 10 power minus 2 Faraday, 1.08 grams. After passing this, how much silver will be available there?
1 minute, ma'am.
Oh,
Zero
0
gram,
grams.
ma'am.
That's right.
I was confused, ma'am.
Okay. So 1 Faraday is nothing but 108 grams of silver. Yet now they are saying 1.08 gram of pure silver was converted to silver nitrate and this solution was taken into the beaker. That means that solution is containing 1.08 gram. So passing this, everything would have got deposited. What will be the silver content that is still left over in the solution? Nothing. So it's 0 gram. Okay, Vaishnavi.
Ma'am, second option.
That's the right one here. Sacrificial anodes or cathodic protections are those which are spontaneously oxidizing themselves. That means their oxidation potential should be greater than iron itself. Right. Next. Deepthi.
Second option.
Very good. That's the right one here. Calcium containing lead alloys or the common replacement for the lead acid batteries. Okay. In place of common batteries, I have mentioned na, that batteries are lead acid batteries. Here the grid, because it is calcium containing lead alloy, okay, they are very much anti corrosive in nature. They withstand lot of lifespan there. Okay, very good. Rima.
Ma'am, second option.
Very good. That's the right one here. Aqueous solution of which of the compound is best conductor of electric current? All of them you can see they are undissociatable. Ammonia, fructose. Ma'am, what about acetic acid? It is dissociatable, but it is weaker one. They are asking for the best conductor. So it is HCl. Kagol.
I'm 1 minute, ma'am.
Okay.
நம்ம ஃபர்ஸ்ட் H plus கான்சென்ட்ரேஷன் கண்டுபிடிக்கலாம் மேம்.
Okay.
அப்புறம் நர்ன்ஸ் ஈக்குவேஷன் யூஸ் பண்ணுவோம்.
Okay. Very good. So as Kagol correctly identified, pH is provided, so it has to be 10 power minus 10, isn't it? They're asking you for the oxidation potential of the electrode here. So usually it's for hydrogen electrode we know how to build the Nernst equation. E is equal to E naught, which is 0, and 2 electrons are involved, minus 0.059 by 2 log of oxidation it is, isn't it? So I read H2 gives 2, H plus is 2 electron. Now this H plus is 10 power minus 10. So calculate your answer here. Okay. Is that clear, Pa?
Yes, ma'am.
Next one. Srinidhi.
Fourth option, ma'am.
Very good, that's the right one here. They're asking you EMF cannot be 0. Why? If they are equal, I can see both are 0.1 molar. That means they have to get cancelled. Then it has to be 0 here, but it is not 0 because their pH cannot be the same. It's a strong acid, it is a weak acid. Though it is 0.1 molar each, their pH won't be the same. Correct. Good. Rima.
And fourth option.
Oh. Think.
Third option,
Why third option?
ma'am. 1 by mn plus will come.
So it has to be positive, isn't it? It should be a positive one. Correct? Yeah, the again is negative here.
மேம் அங்கே லான் வரணும் மேம்.
எங்கடா?
அங்கே லான் போட்டிருக்கணும் மேம், அவங்க லாக் போட்டிருக்காங்க.
சரி, okay. But that's not the major thing here. Our major thing is negative and positive. Okay. Okay, next. But the question here, the silver plating of copper. Okay. This coordination complex is only used rather than AgNO3. Now when I take this copper, you know that copper is more reactive than Ag. So what it will do? It will eventually displace all the silver out. Nalladhu thana ma'am. Having so much silver, easy coating will happen. Remember, electroplating is not just dumping it. It is evenly plating, uniform plating of the metal should happen. For that, very slow, constant release of Ag ion should be there. But here what it is doing, it is completely displacing itself. You can see this here. Complete displacement of silver has happened here. But in this case, it is a coordination complex. We know coordination complexes do not come out of their complex ion very faster. It takes some time. So for even availability, slow availability of the silver ion so that it is uniformly plated, we use this complex rather than AgNO3. Okay. Next question. Next one. Yes, Deepthi. First question.
Fourth option.
Hmm?
Fourth option.
Say it louder, right?
Fourth
Fourth
option.
option. Yes, that's the right one. What is this actually? What compound is this?
Boric acid.
Boric acid. The compound is boric acid. That's right. Srinidhi, next question. Srinidhi, the question is
Yes,
for you.
ma'am.
The question is for you.
Second option, ma'am.
That's the right one here. We know boric acid is a weak monobasic acid as well as a Lewis acid. Boric acid dissolved in water will abstract the OH minus from the water, and the H plus ion is available only from the water, not from boric acid here. Okay, so what are the terminologies we can say? Boric acid is a non-protic acid. It is a weak monobasic acid. It is a Lewis acid. Yes, next one. Tarun. Anyone else who knows the answer can also say the answer. Miduna? What's the formula of borax per Miduna?
Ma'am, Na2B2, sorry, Na2B4O7, ma'am.
That's it.
Dot 10H2O.
Dot NH2O, that's right. Borax is Na2B4O7 dot NH2O. Now they heated to form boric acid here. Always remember, borax when it is treated with HCl will form boric acid. Similarly, when boric acid is treated with NaCl, it will form borax. Borax with HCl will form boric. Boric acid plus NaCl will form borax here. Okay, it formed borax. I heated. It is forming boric anhydride, B2O3. Now there is something that I use. I heat it to form amorphous boron here. Now I say HCl is present in 3 cases here. Now I have Mg here, carbon here, aluminium here. Which one will be able to form boron? I can say it is a reducing agent, isn't it? So that it allows to get oxidized here. I know carbon cannot be that much very powerful element than boron, so that it is going to reduce it. Not possible. So it is eliminated. Between magnesium and aluminium, both can actually reduce boron because they are active elements, magnesium and aluminium. Then why only magnesium? Magnesium will form amorphous boron while aluminium will form crystalline boron. Why, ma'am? Among the reactivity of magnesium and aluminium, magnesium is very reactive. So, like organic chemistry, kinetically favored reaction will be least selective. Faster the reaction happens, ma'am, least selective it is. Slow the reaction happens, ma'am, highly selective it is. Magnesium is very reactive metal. So, what does it do? It just does the reaction very faster, so that the boron is amorphous here. But aluminium is not that much active. It takes its time to do this reduction. So it forms crystalline boron here. Yes, next question. Yes, next question. Kagol.
No.
Let me give you a clue, Kagol. Y is called as inorganic benzene.
Y is called inorganic benzene.
Yes. The Y compound is called as inorganic benzene. Anyone else can also try it.
Option D, ma'am.
Option D is the right answer here. Boron chloride plus ammonium chloride initially forms B3N3H3Cl3. Sodium borohydride is a reducing agent. just like your alkyl halide. Alkyl halide, when you treat with lithium aluminum hydride, you form alkane itself. Same thing. Chlorine is removed here. Instead, another three hydrogens are added. So B3N3H6 is called as borazine, also called as borazole, ZOLE, which is called as inorganic benzene, because just like benzene, instead of boron, carbon, I am having boron here. Okay, next question. I want you to fight among yourselves. Let me give the answer first, then everyone. No competition at all here. Compete between yourselves. There's nothing that why should I be keep on answering the questions. Nothing wrong in it. It's just a competition. Whoever gives the answer first would be better.
Fourth option.
Fourth option, that's the right one here. That means all the other things are the uses of orthoboric acid. Orthoboric acid usually has this antifungal, antimicrobial property. So it is used as an antiseptic, eye wash, it's used in glass industry, it's used in glazes for pottery. Of course, not in borax bead test. Okay, next question. Quick, 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 fast, fast.
Option D, ma'am.
Option D is the right one here. The factor responsible for weak acidic nature of BF bonds in BF3. We have discussed about the acidity trend of boron halides from BF3 to Bi3. Here BF3 is least acidic compared to Bi3. We are not saying it is not at all acidic. It is acidic only, but weak acid compared to Bi3 because of this P-pi back bonding. So important concept is back bonding in inorganic chemistry. The back bonding is very effective between the second period elements, among the second period elements, because of their small size. Once they go down the group, the back bonding efficiency actually decreases. We have three types of back bonding: P-pi, 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 D-pi, D-pi, D-pi back bonding. So what kind of a central element can accept this electron? Number one, if they are they are having octet incompleteness. Number two, if they are having super octet efficiency, then they can go for back bonding. Yes, next. Borozone. Borozone is nothing but called as boron nitride. What is boron nitride? Boron nitride is very strong, just like diamond. It is very strong as borozone or boron nitride. So diamond is nothing but sp3 hybridized. sp3 hybridized is non-planar. It is tetrahedral, isn't it? So it is non-planar. Borozole, as I mentioned, borozole is another name for borazine. Does it look like benzene? Then it has to be planar. B3O63 minus. Look at the structure of B3O63 minus. Doesn't it look like the conjugate base of boric acid here? Can you see this? Boric acid also forms hydrogen bonding type, isn't it? They are also two-dimensional layered structure, which is also planar here. Shall we go for the next question? Next question. If you have forgotten, no issues. Diborane plus potassium hydroxide. You can see potassium is a very active element there. Boron cannot displace it. So it has to form an salt only. Potassium metaborate. Hydrogen gas liberation here. Similarly, aluminium is not that much reactive to displace potassium from potassium hydroxide. So here it is forming potassium meta-aluminate. Just like the reaction that you have studied, aluminium plus sodium hydroxide, isn't it? You see it is forming sodium meta-aluminate, NaAlO2. Similarly, it forms potassium meta-aluminate.
Ma'am, first option.
First option is the right one. Very good. When you take borax, you treat it with HCl. I said it would be forming boric acid. The reverse reaction also I told you. Boric acid plus NaCl will form borax here. So the formed one is boric acid here. Boric acid upon heating forms HbO2. What is the name of HbO2? What is the name of HbO2? Metaboric acid.
Emboric acid.
Huh? Sorry, da. HbO2 is called as metaboric acid here. Now upon heating it faster at a red heat, it will completely become an anhydride, boric anhydride, B2O3. Now the next reaction. Boron trifluoride plus lithium aluminum hydride. Always remember, boron fluoride, when it is reacting with different reducing agents, it could be sodium borohydride, it could be lithium aluminum hydride, anything, that will give you diborane. Next one. In the second equation, it is boron trifluoride with sodium borohydride.
Second option, ma'am.
Second option, that's the right one here. Sodium borohydride, when it is treated with iodine, is giving you diborane. You can see the clue here is that everywhere it is only X, so it has to be diborane only, as I mentioned. Boron trifluoride with any reducing agent is going to give you diborane, so it is diborane here. Along with it forms sodium iodide as well as hydrogen here. Okay. Yes.
Ma'am, second option.
Yes, that's the correct one here. 3 center 2 electron as well as 2 center 2 electron bonds. Is there anyone who wants me to reteach diborane structure? Anyone? Or you are comfortable with diborane? If you want, I will reteach it faster. Quick. So everyone knows.
Repeat once more.
Okay. Boron initially is coming from the 13th group element or the third group element, as we know. So what it would do, it will come with 3 electron, 1, 2, 3. With its hybridized orbital it will come, isn't it? Because boron always, you can see it is forming sp2 hybridization, so 3 hybrid orbitals it has come with. Similarly, another boron, 1, 2, 3. Now we are talking about diborane, which has got dimerized from borane here. So that means an hydrogen also comes with one unpaired electron, isn't it? Each hydrogen has come with one unpaired electron here. It has got formed. Still you can see boron, each boron is having only 6 electron. So it should be actually unstable. But what boron does is that it brings its unhybridized orbital. Boron brings its unhybridized orbital here with as no electron. It is having 0 electron here, no electron at all. Similarly, this boron. Here also one hydrogen came up. Okay. This boron also came up with no electron here. You can see now it has formed a banana bonding here. Just like a banana it is. So we call this banana bonding. Now the question is whether this B2H6 is not a Lewis acid now. Is it not a Lewis acid now? BH3 is a Lewis acid. Incomplete octet. What about B2H6? B2H6 is also a Lewis acid. Still you count the boron count is only 6 electrons here. Then why is this orbital coming for bonding here? It is just coming for bonding so that it can stabilize the borane here in this atmosphere. In the common nature, it has to get stabilized. So it exists on its own as B2H6 here. Now the question is about the 3 center 2 electron bonds here. So we are talking about 2 center 2 electron bonds. Look at this, 1, this is 1, this is 2. 2 center, how many electrons they have got? 1, 2. Similarly, this is 1 center, this is another center. How many electron? 1, 2. So in the left hand side, I see there are 2 center 2 electron bonds. Similarly in the right hand side, 1, 2, 2 electron, 1, 2, 2 electron. So totally I have 4 2 center 2 electron bonds. Now talking with respect to the 3 center 2 electron, look at this. 1 center, second center, third center, 3 center it is. How many electron? 1, 2. Similarly this side, 1, 2, 3. 3 center, 2 electron bonds it has got. How many? 2. So diborane is having 4 2 center 2 electron bond and 2 3 center 2 electron bond. Now the hydrogens that you see in the terminal positions will be denoted as HT, and the hydrogen in the bridging position will be denoted as HB, or bridged hydrogens. Whenever they form some compound, ma'am, the diborane is there, B2H6 is there, I am treating with some other element, let me say some M element is coming for its reaction. 2 hydrogen should definitely be available with diborane. You can't extract these 2 hydrogen from the bridging position. They will always be available. You cannot extract all the hydrogen from diborane. Very common question. What is not possible? Less than this 2, it's not possible. It should always retain 2 hydrogen. Now talking about the bond length and the bond angle. The bond angle of this bridging one will be less. Bridged bond angle will be less than the terminal bond angles, because they are coming close with each other, bending themselves to do this bond. If I talk about the bond length, bridging bond length will be more than the terminal bond length, because they are extending themselves to do this bonding. Okay, so these are the very common questions from the diborane structure. Yes, let's go on. So the question is asking you, it's having a 3 center 2 electron bond here. Now it is reacting with the ammonia gas at certain temperature, gives compound Y here. Okay, So when it is reacting with lower temperature, when it is reacting at a lower temperature, it will form a dot product. Look at this, B2H6.2NH3. Further heating it will give you borazole or borosine. They mention it is isostructural with benzene, so it should be borosine. Now if this compound is treated at high temperature, low temperature forms dot product, again heating forms borosine. If it is high temperature, what you get is boron nitride here, BNX. Okay, next question.
Second option, ma'am.
Very good, that's the correct one here. Boric acid is having hydrogen bonding ability, so it is polymeric in nature. Yes. What is the hybridization of boron and boric acid? Kabul?
Ma'am,
Hmm.
ma'am, can you repeat the question, ma'am?
Hybridization of boron and boric acid.
Ma'am, sp3, ma'am.
sp2. 3 bonds only it will make boron in boric acid. So yeah, so it is sp2.
Okay.
Next. Tarun?
Yes, ma'am. 14th or 13th, ma'am?
13th.
13th. It's 3, ma'am.
It's 4, da. This is borax, isn't
But,
it? Each boron is bonded with OH here. Okay.
yes, ma'am.
Vaishnavi, tell me the hybridizations of boron here.
SP3.
All are sp3.
Ma'am, the top and bottom ones are SP3. The side ones are SP2.
sp2, correct. So they'll be asking you the boron hybridization and borax. Okay, borax has two different hybridization, but boric acid, which we have studied just dealt now, is having only one hybridization, sp2 hybridization. Okay, next one. Generally, whenever you are having borides, that means the element bonded with boron. Okay, when you treat with acid, they will form boranes. Boranes means boron bonded with hydrogen. That is boranes. Next one.
Third option, ma'am.
Correct. Just a clue. Tetraboric acid, so it has to have 4 borons here. Rima?
Fourth option.
What's the formula, da? Borax formula?
Na2B4O7.
Only that. What is the dot product? Dot 10H2O, isn't it? Your answer is correct, but your formula it's incomplete here. Na2B4O7 dot 10H2O. So you can look at the formula here where you are having 20 hydrogens, and similarly you will be having same amount of oxygens that is provided here. Okay, 17 oxygens are available here. Next one. Deepti?
Fourth option, ma'am.
Very good. Because we just now learned boric acid is a monobasic acid, that means we can learn other 3 options here. Boric acid is used as a food preservative. That is a note added point that you have to remember. Other than that, as I told you, they form layered structure here through hydrogen bonding. It is a weak monobasic acid. Yes, next one.
Second option.
Second option, very good. We just now discussed. Borax has two types of hybridization, sp2 and sp3. Okay, next. Ragul.
Ma'am.
Vara.
Yes, ma'am.
Faster. What have I told you? Whenever you're having this kind of correct or incorrect, go for first and fourth option. Then you can move between the options.
Okay. Fourth option, ma'am.
Fourth option, that's it. That means other options you should know. As I mentioned again, boric acid plus NaCl will give borax. Just reverse. Borax plus HCl will give you boric acid plus NaCl. Boric acid plus ammonia will give you boron nitrate. Boron nitrate plus water will give the reverse here. This is a constant heating reaction of boric acid here. Gives metaborate, tetraborate, then finally boron anhydride. Last question. We'll complete the last question with Miduna. Yes, last question.
Ma'am, third option.
So then what is the phase of boron trifluoride?
Ma'am, I did using elimination, ma'am.
Okay. BF3 is a gas. Okay. Fine. So in this session we have did a quick revision of electrochemistry, concentration cells, and p block elements, boron family, not boron family, boron. Okay. We'll continue in our next session. Bye.
Thank you.
Thank you.
ஃபோன் பார்த்து எழுதிட்டாங்கன்னா என்னம்மா பண்ணுவேன்?
உங்களுக்கு தான் லாஸ், எனக்கு தான் லாஸ்.
மால்டி